All right, time for tutoring video number 3. This video is going to be about working with students on physics and chemistry. When students are struggling with physics and chemistry, I mean first year physics and chemistry, not like 12th year advanced inorganic, no, just normal physics and chemistry. If they're struggling with it, 99% of the time, here's what's happening. They are simply not visualizing the thing at all. They are viewing this as just a series of formulas and abstraction, and they're not imagining it, right? They're not imagining two atoms. They're not imagining two atoms sharing electrons or sharing them unequally or anything. They're visualizing absolutely nothing. And this is a common thing that people do. If you don't understand a thing, or if you just, for whatever reason have an aversion to it, you'll do what I call distancing, which means you just keep it as far away as possible. But before we do this, I'm going to give you an example of what I mean by distancing, right? So you suppose a student knows that the radius, the area of a circle is pi r squared, right? And if you give them this problem, they'll be able to do it, all right? But what they're doing here, if they don't know what a radius is, and you give them this problem and say make this 6, the diameter is 6, they won't know how to do it. They'll try to find a new formula that connects the diameter to the circle. Because here's what they're thinking. They're thinking, I don't know what a radius is. I don't want to know what a radius is. And so just don't let the idea of a radius or the image of a radius in my mind, right? And that's what you'll see a lot of in physics and chemistry. Now, it's not because people don't want to do it. It's just because they have such a high aversion, such a high phobia of it or whatever, they can't do it. And so what we need to do is a few things. One, really actively have them visualize things. You can pause and say, actually imagine it. And when they say, and you ask them again, are you imagining? They're going to say, okay, no, I wasn't really imagining it. And it might take you a few tries. But a lot of it is going to come down to some of the techniques that you choose to use. Now, as you guys know, there are many ways to do the same thing. In this case, I'm going to illustrate this with a basic physics concept, adding two vectors. Now, there are many ways to add two vectors. I mean, at the basics, you do need to kind of have them tip to tail, but from there, you can do anything you like. You can, from here, you can use the law of cosines. You can draw that not very good along the side of the triangle. You can do, that C equals a squared plus b squared minus 2 ab cosine the angle C, and you can do it like that, right? And it'll work. You can also the problem though with using the law of cosines here is what you're doing is you're enabling that formula way. I'm not going to visualize anything. I'm not going to imagine anything. I'm not going to do any of that type of thing. You can use the parallelogram method, right? You get yourself a little parallelogram here. You find the diagonal. You can do that too. Now, it's not that those don't work. It's that they're a bad idea to teach because it really actively encourages somebody to distance themselves. Some of you guys who are super, super advanced in math and science and everything on Earth, you can probably visualize and conceptualize something in terms of the law of cosines, and it like makes concrete sense to you. And that's awesome, and it's impressive, but trust me on this, that doesn't work for 99.999% of the human population. The 99.999% of the human population cannot like concretely visualize and really hold that in their mind, the law of cosines. They can memorize the formula. They're not going to like understand it deeply. So how do we teach this? Well, the way that we teach it, the way that I would recommend teaching this is just the most simple way. Start off by breaking the vectors into components, and right here, you're going to see what the underlying problem is because most students say that's the first area that they get stuck. Breaking vectors into components, that can be a couple lessons, teaching people about sine and cosine and how you break things into components, all that. And you break this into components. And notice you're doing a very physical thing here, right? You are showing that there's a horizontal component. You are showing there's a vertical component. A student can imagine that this thing is going both up and to the right, but it's going more to the right than it's going up. Then what do? We add all the horizontal vectors to get this big thing, and we add all the vertical vectors to get this thing, and then we find the resultant using the Pythagorean theorem. Now, that is technically slower than just using the law of cosines. I mean, I can see that. But it ensures actual understanding. The short-term speed will come at a long-term high guarantee of forgetting every single part of it. What you want to think about when you're doing physics or chemistry or anything that's very concrete, any part of math that not Euclidean geometry necessarily, but like the shapes math, right? Finding volumes and areas and all that, is you want to ask yourself, what is the simplest bit of physical thing that they're not thinking about, and get to that. With physics, it's almost always vector. I mean, it's 99.9% of the time it's vectors, understanding that vectors can be broken into components and being able to do it. Students will see that it's happening, but they won't get what's going on. And if you're just patient with that and make sure that they're actually understanding it and visualizing and understanding that you're going more to the right than you're going up and all that, then you're going to be able to get a long-term understanding. The key here is this. When you're deciding between different ways of teaching the same thing, and most things in physics and chemistry can be taught in 50 different ways, you want to ask yourself this: does this enable distancing? In other words, does this enable a student to just learn the formula and then forget it? You should never prioritize speed over concrete understanding. If you put speed first, they'll be quick for that one lesson, but they're going to forget it, because speed first basically is going to come from whatever's the shortest formula. The shortest formula is also going to be used with the least physically intuitive formula. So, long story short, make sure that they're physically understanding the basic physical thing. Even if you think it's way so simple that they would never not be able to understand it, check it anyway. If you want to know what some of the things to look for in physics are, it's just vectors, always vectors. The next thing to look for in physics is, and we'll talk about these in some of the other videos, but in physics, you just check to see if they understand what normal force is. Make sure they understand that normal force is not just the up force, that it's the repellent force that stops you from walking through a wall, that kind of stuff. If you're doing chemistry, this is sometimes I came at discussions with me and Kimya, and Kimya pointed out that the big issue that people have in chemistry is they can get the idea that atoms can share electrons, but they don't get the idea of this unequal sharing. They don't get this idea of the tug of war, that one side can have more of a pull on the electron and become a little bit negative. So wherever you're going with this, make sure you're focusing on the concrete, the physical understanding of this, and not letting kids just slip into whatever's the quickest short-term formula.